Alright, this month got off to rather an explosive start. And so, because of this, there's 4 very cool things that this very detailed spectrum reveals. Which means that this dense cocoon scenario might just be the way that the majority of black holes in the early universe grow to become so supermassive. Welcome back to Night Sky News for June 2026 with me, astrophysicist Dr. Becky Smethurst. In this episode, we're chatting all about the big news from JWST that we're getting closer to an explanation for the little red dots. Plus, we've got the latest Artemis drama from explosions to the announcement of the crew for Artemis III. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mentioned are all going to be linked in the description down below, free to read. But before we get to the latest space news, as always, let's kick things off with a quick recap on what you can see in the night sky in the next few weeks. And let's start by looking up. June can only mean one thing in terms of astronomy, and that is the solstice, which this year was on the 21st of June. In the southern hemisphere, this marks the shortest day and the start of winter, with ample night sky viewing opportunities and the best views of the Milky Way. But in the northern hemisphere, it marks the start of summer with the longest day, meaning for many of us, the sky just isn't getting dark enough to see that many stars because the sun is only dropping a few degrees below the horizon after sunset before it rises again. For example, here in the UK, the sun doesn't drop low enough below the horizon for us to officially enter the definition of nighttime for a month either side of the solstice. We stay officially in twilight all night. So really up in the northern hemisphere, we're only limited to the brightest night sky sites at the minute, so that's the moon, the planets, and the constellations. If we start with the moon, because that's going to be officially a micro moon when it's full on the 29th of June, that means it's going to be further from Earth than normal because the moon's orbit isn't a perfect circle, it's an oval shape, so the distance to the moon from Earth varies quite a bit. This changes the size of the moon in the sky as well, meaning that when it's a micro moon, it's technically smaller in the sky than normal, but it just isn't noticeable to our eyes. You don't have a normal moon to compare it to. You'll also hear this referred to as a micro strawberry moon. Strawberry being the term given to any full moon that falls in June. It's not an astronomy definition anyway, it's just like a colloquial term for it, so don't get excited when you hear this. The moon's not going to look red or like a strawberry or anything. What is fun to get excited about though is to notice how low the moon is in the sky at the minute. So on the 29th here in the UK, the moon only rises 9 degrees above the horizon. That's because the full moon is always in roughly the opposite direction in the sky from the sun. So around solstice, when the sun is rising really high in the sky during the day and then barely dipping under the horizon at night, the moon is barely bobbing above the horizon at night. So if anything, this is going to make the micromoon look bigger than normal because of what's known as the moon illusion near the horizon. And it could give it an orangey tint too because the atmosphere is thicker on the horizon, so you get a lot of scattering of blue light, just like what happens during a sunset, to leave it looking a lot more orangey and red. So I can just see like the miscommunication happening online right now of people read, you know, like micro strawberry moon and expect something that looks very small and red and instead get something that probably looks larger than normal because of the moon illusion and slightly orange instead. But this is going to look really atmospheric, so I'm going to make a special effort to try and watch the moon rise on the night of the 29th of June. Some weather apps will actually tell you like what time the moon rise is going to be, but I'll pop a link in the description below to a site that can give you the specific time for your location so you don't miss the full moon rise on the 29th. After that, the next time to look out for the moon is when it will handily signpost both Saturn and Mars in the morning skies. So Saturn is rising around about midnight at the moment. It has that slightly yellowish tint to it that lets you pick it out from the background stars, whereas Mars is rising early in the morning and it has its reddish tint. But if you're not sure what you're looking for and everything's just blending into the background stars, then this is where the moon comes in really handy as a signpost, a marker for where to look. So between the 7th and 12th of July, the half moon will first swing past Saturn on the 7th and 8th before making its way towards Mars and the Pleiades star cluster as a crescent moon on the 11th. So if you're up late or early for whatever reason in that first week of July, maybe like me here in Europe, you'll be watching some World Cup matches at funny times during during the night, then see if you can also spot Mars, the Moon and Saturn. Now technically Uranus is also in that mix as well, but you won't be able to see that with your naked eye. You're going to need binoculars or a telescope to see Uranus because it is just too faint. And the best night to break those out if you're thinking about doing this is the 4th of July, when Mars and Uranus have a conjunction. That just means as everything moves along their orbits, they're going to come really close together on the sky from our perspective here on Earth. Of course, in reality, they are in fact separated by a huge distance, but they'll be coming just 0.1 degrees apart from each other. That's about a fifth of the width of the full moon. So they're easily going to fit into a single field of view of your binoculars and maybe a telescope, depending on what lens you use. And the much brighter Mars will act again as a nice signpost for finding Uranus if you've never been able to spot it before. Now, if you want something that's slightly easier to spot than Uranus, then the other thing to look for this month is Venus. It is the brightest thing in the sky after the moon, meaning it's one of the first things to appear after the sun sets. It is dropping very quickly through July though as it moves around its orbit, so spot it while you can this next month. Friday the 17th is when the crescent moon will join it just after sunset and create that picture perfect moment. Alright, that's it for looking up at the night sky, but before we chat about what's been happening in space news, I just want to say a big thank you to the sponsor of this week's video, Mel Science. Mel Science is a subscription-based service that provides physics and chemistry experiments for kids and young learners. Because parents ask me all the time for ideas on the best ways to nurture their kids' love of science. And I think the Mel Science subscription boxes are a perfect way to do just that. Each kit includes a real science experiment, high quality materials and step-by-step instructions. Since I'm a big kid, I've been sent their Spectrum kit to play with, which I am so impressed by. So much of what us scientists know about the universe comes down to splitting light into its rainbow, its spectrum. So spectroscopy comes up all the time in astrophysics and in the explanations in my videos. So being able to get kids curious about these techniques in such an engaging way is honestly, it's so cool. Plus, together with the hands-on kits, your kids get access to immersive experiences, including an interactive mobile app with virtual and augmented reality. And I think the fact that these kits are designed by real scientists and educators to make the science accessible and safe is what makes them so genuinely exciting. So if you've got a kid in your life that you know would absolutely love a Mel Science experiment box, go to melscience.com and use the code DrBecky12 to get a year of science for just $22.45 a month. That offer is time limited though, it's only available until the 3rd of August. So thanks again to Mel Science for partnering with me on this video, and now let's come back down to Earth and chat about what's been happening in space news in the past month. Alright, this month got off to rather an explosive start with the unplanned explosion of Blue Origin's New Glenn on the launch pad on the 28th of May. Now, as far as I can tell, I don't think this is going to have any impact on astrophysics research, thankfully, because there were no plans for New Glenn to launch, like a planetary science mission or a telescope. So there's no impact on, say, NASA's Nancy Grace Roman Space Telescope, which is set to launch at the end of August. But New Glenn was set to be a part of the Artemis missions, so the missions that are set to return humans to the moon and deliver the first components of a moon base to the moon. Which means the success of Artemis is now riding solely on SpaceX's Starship, which has its own development challenges. So there was already a lot of doubt whether NASA was actually going to be able to stick to the ambitious schedule that it set itself for the Artemis missions and putting humans back on the moon. And this just seems to have made things a whole lot worse. Speaking of maybe making things worse, NASA also announced the crew for the Artemis III mission this month. So this mission won't take them back towards the moon like Artemis II, where they looped around the moon. This is just going to be a technology test of the newly developed lunar landers. So they're going to fly into low Earth orbit and do all the tests that they need before actually taking it to the moon for the landing attempt in Artemis IV. So, the crew for Artemis III is set to be Commander Randy Bresnik, mission specialists Andre Douglas and Frank Rubio, all of whom are from NASA, and then pilot Luca Parmitano from ESA. Now, first of all, we've got to acknowledge and celebrate the increased race diversity in this crew. But let me add my voice to the growing list of people that are disappointed to see that this is once again an all-male crew. Now, Jared Isaacman, the director of NASA, has put out a statement acknowledging similar reactions, which basically says don't read too much into it. We have lots of qualified women at NASA, and these 4 men just happen to be the most qualified people for this specific mission. I'm paraphrasing the key bits from his full statement there, which honestly, that first paragraph made me more angry. If anything, I genuinely thought it was a parody statement when I first read it. It really was just a masterclass in what not to say in this situation. So a lot has been said about this all-male Artemis III crew already. But let me add this thought purely from a statistics perspective. So if you draw randomly 3 people from the current list of 37 active NASA astronauts and then 1 person from the 11 active ESA astronauts, the probability that you get an all-male crew is 14%. The most likely scenario is 3 men, 1 woman at around 38%. That's what we had for the Artemis II crew. And then the second most likely scenario is 2 men, 2 women at a probability of 34%. Now, of course, we know crew selection isn't random. It's based on experience and skill sets and availability of the astronauts. But if you assume those things are independent of gender, which they should be, then these stats still apply here. So the Artemis III crew isn't statistically anomalous in that it's an all-male crew once again. We can just add it to the ever-growing list of all-male spaceflight crews that have come before it, right? And I think that's what feels just so especially frustrating when it comes to this, is that despite all of the progress that we've been hearing about, you know, to take us towards equality and equal representation of women in this field, like for example, the most recent intake of NASA astronauts had 6 women and 4 men in the class, making it the first time women outnumbered men in an intake, or the first all-female spaceflight crew on Blue Origin in 2025, or the first all-female spacewalk with Christina Koch and Jessica Meir on the International Space Station in 2019. But then you get this announcement of the Artemis III crew, and that's why it feels like a step backwards, not forwards, at least in terms of gender representation. So I'm just going to keep looking at these stats for random draws from the current crop of astronauts just to try and reassure myself that in all likelihood the crew for Artemis IV, which is the mission that's planning to try and land humans back on the moon again, should have at least 1, if not more, women on the crew. I mean, there's even a 1.5% chance it could be an all-female crew. What I will say is the chance of back-to-back all-male crews being randomly drawn from the current astronaut crop is 1.6%, or a 1 in 61 chance, which would be statistically significantly anomalous. It would be like flipping a coin and getting heads 6 times in a row. That'd be about when you'd start to get suspicious if you had a biased coin. So I'm willing to put this all-male Artemis III crew down to the fact that, yeah, these were the 4 best people for this mission, and they just all happened to be men. But if this happens again for the next Artemis crew, that's when I'm going to start flipping tables. All right, let's actually chat some science now, because we've got closer to solving the mystery of JWST's little red dots this month, thanks to this research paper by Kokorev and collaborators. So first, a quick recap, because the little red dots were found as part of the search for growing supermassive black holes in the distant universe, which we see as it was billions of years ago because light takes time to travel to us. Now, specifically, people were looking for emission from hydrogen gas, which glows at a very specific wavelength or color of light. And if you've got hydrogen that's spiraling around a supermassive black hole because it's taking that material in slowly but surely and using it to grow in mass, to get heavier, that hydrogen is moving at incredible speeds towards and away from you, which means that the light that it's giving off gets Doppler shifted, stretching out the wavelength of light for hydrogen moving away from you and squishing the wavelength of light for hydrogen moving towards you. That takes the big spike of light from hydrogen that we get in a galaxy's spectrum. So when we take the light and we split it into how much light at each wavelength or color are we receiving, and it smears that spike out. We call these broad lines in the spectrum, and they act as a signpost to tell us there's a growing supermassive black hole at the center of these galaxies. And when people went searching for these broadened lines in JWST spectra, they found a bunch of them. And they became candidate AGN, active galactic nuclei, i.e. candidates for growing supermassive black holes in the early universe. Candidates only because they hadn't been confirmed by other observations yet. But when people then looked at the images of the galaxies, so they found the broad lines in the spectra and then went, okay, well, what do the actual galaxies look like? They found that they all had this similar look to them of a compact red dot. So then people then went searching for these compact red dots in images taken by JWST in the hope of finding growing supermassive black holes that way for things that they didn't have spectra for yet to look for those broadened lines. And they found thousands. These things aren't rare, they are absolutely everywhere. But then to confuse things more, when people then got spectra of the things that they'd found in images that looked like little red dots, those spectra didn't always have broad emission lines in them. So it's a bit of a mystery what we're seeing here, because they don't really look like anything we've seen before, so they're not easy to explain. They also have this distinctive V-shaped spectrum with lots of blue light and lots of red light, but a sharp dip in between. And it's when you try and explain this that you start to run into trouble, because one explanation, for example, is that they could be incredibly massive galaxies in the early universe. So just a big blob of stars that's formed really quickly all at once. But Labe and collaborators in 2023 showed that the mass you need in stars to make that work is just so enormous that it would break our best models of the universe. It just shouldn't be possible for that many stars to form that quickly, although this seems like a little bit of a trend with JWST observations, because it's not just the little red dots that are suggesting that, it's other galaxies too, which is a whole separate JWST problem that I've talked about before on this channel. So the other option to explain the little red dots is dust. Bigger, heavier molecules that block some of the shorter, bluer wavelengths of light, but that longer infrared light happily passes around. So a very dusty star-forming galaxy could end up looking like a little red dot in an image. The problem with that idea, though, is that if there's dust there, it should also be glowing in longer infrared wavelengths of light. But Casey and collaborators in 2024 looked for that, but it's not there in detectable levels. So it's probably not dust, which then brings us back full circle to the third option, that they're growing supermassive black holes in the early universe. Like first thought, because of the broad lines in some of their spectra anyway. But this explanation also has problems. Firstly, because the black holes would have to be way too overmassive, have grown too quickly for that point in the universe's lifetime. And to top it off, the little red dots don't seem to be visible in either X-rays or radio waves like we'd expect from a growing supermassive black hole. Although Glaumans and collaborators did report detection of one little red dot out of a sample of 700 that was detected with radio waves. But you would expect that to happen, to have no X-rays and no radio waves, along with that weird V-shaped spectrum, if the growing supermassive black hole was hidden away inside a cocoon of very, very dense gas. The dense gas would scatter the X-ray light so many times on its way out from that accretion disk around the black hole, so that by the time it makes its way out, it's lost so much energy that it's now visible in the ultraviolet or visible light, maybe explaining that blue upturn to the spectrum. So the idea is that all the little pieces of this puzzle that we've observed are coming together to give us this explanation of a little red dot as reprocessed light from the material that's spiraling around a supermassive black hole that's cocooned in a dense ball of gas. Now, this hypothesis that has emerged over the past few years is annoyingly known as the black hole star model, because it's represented as BH asterisk in research papers, in the same way that the Milky Way's supermassive black hole is known as Sagittarius A star. It's really Sagittarius A asterisk. I know it's incredibly confusing because it quite literally has nothing to do with stars, but the point is, this black hole buried in a cocoon of dense gas is the hypothesis we need to test. So that's what Kokorev and collaborators were trying to do when they observed the little red dot known as Glimpse 17775 using the NIRSPEC instrument on JWST for 20 hours to try and collect as much light as possible. It's around 11.5 billion light years away, which means that we're seeing this galaxy as it was when the universe was just 2 billion years old. And the spectrum they got of it with JWST is so incredibly detailed. They spotted over 40 emission and absorption features, so those spikes and dips that are the glow of specific elements like oxygen and silicon and hydrogen that each happen at these unique wavelengths of light. Just to put this into perspective, that the other spectrum that we have of little red dots that have been taken in more of a survey mode of observing, where it's a very sort of quick snapshot that you get, are a lot noisier. And so I've only detected a handful of these features at best. And so because of this, there's 4 very cool things that this very detailed spectrum reveals. First of all, the shape of the emission lines themselves, which Kokorev and collaborators were able to get good enough data to resolve. So instead of like the smooth normal shape that you'd expect from the Doppler shift that's happening in the accretion disk around the black hole, which is shown here by the blue curve, these spikes actually have these extra wings to them, which is shown by the fit in the red line there to the data in the black. This is the fingerprint of this light has been scattered through some very dense gas. Secondly, the detection of very strong helium emission, that only can happen in very dense gas regions. Similarly, there's also a pair of oxygen emission spikes that come from fluorescence that's caused by the combination of the speeds you get around a growing supermassive black hole and reprocessing through incredibly dense gas. And finally, there's also all of these ion emission spikes as well, the pattern of which matches what you predict you'd get from incredibly dense gas surrounding a supermassive black hole. Add to that the drop-off in bluer wavelengths of light in the spectrum, and you've got 5 pieces of evidence that are all pointing towards this explanation for this one little red dot of a growing supermassive black hole cocooned in dense gas. Now, of course, the big question is whether this is actually representative of all of the little red dots, which we don't know. This one, Glimpse 17775, could turn out to be a bit of a weirdo. But it's worth saying that of those 5 pieces of evidence found here, they have all been found individually in more noisy spectra of little red dots before. Which means that this dense cocoon scenario might just be the way that the majority of black holes in the early universe grow to become so supermassive, rapidly and messily hidden behind all of this gas that blocks X-rays and makes them look nothing like the supermassive black holes that we see around us today. And it's only now, thanks to 20 hours of staring at just a single little red dot with JWST, that we're beginning to see what's actually going on inside these little red dots. Alright, that's it for Night Sky News for this month. Sort of, anyway. I originally wanted to include some more cosmology drama that's going on, because there's a big argument going on right now in research papers over whether there's evidence to support the idea that the universe's expansion rate is decelerating, not accelerating like we've thought for a long time. But I quickly realised that needs to be like the whole video by itself, so look out for that coming out on my channel very soon. In the meantime, if you snap any pictures of the night sky or you see any space news stories that you want me to explain in a future Night Sky News video, then send them my way over on social media, because I'd always love to see them. But until next time, everybody, happy stargazing. I thought I put do not disturb on, and yet I am getting disturbed. Welcome back to Night Sky News for June 2026 with me, astrophysicist. That was a real... Who's got 2 thumbs? Claw clipping, because it is just too warm in this room to do anything. I don't have a mirror to check how that looks, but hopefully it's one of those like, I just threw it up and now it looks fine and not I'm an absolute hot mess. I don't know, I think it looked better before I faffed with it. Classic. Alright. As always, let's kick things off with a quick look at what you can see in the night sky in the next few weeks. As always, let's kick things off and start by looking at what you can see in the night sky in the next few weeks. As always, let's kick things off with a quick recap of what you can see in the night sky in the next few weeks.